Time with this one. So besides just doing the ones that were missed, I weighted these. So not only were these all the ones missed the most, like the ones that are towards the beginning were missed even more than the ones like as we move on, it gets a little bit better. They're still all bad, but it gets a little bit better, just in case we run out of time. I'd rather tackle the ones that like nobody got. So the value of stock A T months after it is purchased is modeled by this function that appears to be quadratic. Square there. The value of stock B T months after it is purchased is modeled by this other function. That one appears to be exponential. Based on the model for which T values is the value of stock B greater than stock A. So you'd have to go in and check all of these to see which ones give you a bigger B than A. Now also, what would help you out if you remember which types of functions get bigger faster, exponentials or quadratics? The exponential. So, especially as you get further and further towards positive infinity, the exponential is going to get faster than a quadratic would be. Like if you look at a parabola, at the right side of a parabola, it looks kind of like an exponential growth. That's the same shape as an exponential growth. It's just that an exponential growth is going to get bigger faster. So, we'll check the ones towards the beginning, but once we see that the exponential function is bigger, it's pretty safe to assume that it's gonna stay bigger for the rest of the t's. So let's see t at 5. So if I do VA at 5, it's 5 squared plus 1.5, which I know is gonna be 26.5. If I do VB at 5, it's going to be 10 times 1.25 to the fifth. Here's where the calculator comes in. I can't do that in my head. I would need a calculator for that. 1.25 power 5 times 10. I'm getting 30.52 around there. So which one's bigger? Based on this model, for which t values is the value of stock B greater? Yeah, B is greater, so okay, that would be one. Let's see the next one. It might be bigger for all of them. Let's see. So 6 squared plus 1.5 is 37.5. 1.25 power 6 is equal to times 10. I'm getting 38.1. Um, but it is a little bit closer though. See, before B was a lot bigger. So I mean, I guess it has to do also with the base and what you're multiplying by. Um, maybe that growth of 1.25 is not enough of a growth factor to keep up with the squaring of the 6. So I guess we gotta test each one. Let's try 7. 7 squared plus 1.5 is gonna be 50.5. And then volume of B at 7 is 10 times 1.25 to the 7th. 1.25 power 7 times 10. This one's giving me 47.7. So I was wrong originally. Even though exponentials get bigger faster, the growth factor isn't enough to keep up with the square. So far we have A and B as an answer, but C is not going to be an answer. And it's pretty safe to assume here. Let me just do it on the calculator to save time. 11 squared. I know that here. This is BA at 11 and VA at 12. That I can do in my head. That's quick. 11 squared is 121 plus 1.5 is 122.5. 12 squared is 144 plus 1.5 is 145.5. So 1.25 power 11 equals times 10. 1 plus power 11 times 10. I'm getting 116. Yeah, so B is smaller for 11. It's going to be smaller for 12 also. So it wasn't a big enough growth factor. If that growth factor, like if the 5, the 6, and the 7 would have been the base, um, or even for that matter, if you would have had just a slightly bigger base, maybe if the base would have been 2, that would have been enough. But it's only A and B here. Any questions, Kiara? Well, I did it on the calculator. I was doing it verbally because I can't do those in my head, but I just did it to check it. And this one over here, the VB at 11, it came out at like 138, something like that. It was less. So, I started off with 2 were bigger, but now I'm seeing that as my T's get bigger, um, the red one is staying ahead. So I didn't even bother to do the last one because it doesn't seem like it's gonna be. Just trying to get through as many problems as possible. But that's, yeah, the exponential is pure calculator. I'm just using the calculator. At the beginning of an experiment, the number of a bacteria in a colony was counted at time t. The number of bacteria in the colony t minutes after the initial count is modeled. Okay, so they already modeled it for you. Which value and unit represent an average rate of change? What does average rate of change mean? It's the same thing as slope in the number of bacteria for the first 5 minutes of the experiment. Okay, so our first amount is at 0. When time is 0, how many bacteria are there? No, not 0.
Oh.
It's 4, yeah. And if you're not sure, plug in a 0 here for t. 2 to the 0 is 1 times 4 is 4. How many, and then in 5 for the first 5 minutes. So if I were to plug in a 5, 4 times 2 to the 5th, I know 2 to the 5th is 32. Times 4 is that 128. So 5, 128. So then you just have to select all that apply. The first thing I'm going to do is pick the slope. So it's going to be 128 minus 4 over 0 over 5 minus 0. And that's 124 over 5. Since they have everything as a decimal, I can tell that they divided. So I need to divide 124 divided by 5 is 24.8. That's B. And then remember, it's a rate of change. It is a ratio. Slope is a ratio. It's a comparison of 2 numbers. What were we measuring on the 124? What were, like, the 128 and the 4, what were those measurements of? Bacteria. This was bacteria. And then what was the 5 a measurement of? It was time, and time was being counted in minutes. So the unit here is going to be bacteria per minute. So 24.8 bacteria per minute. Bacteria on top, minutes on the bottom. Any questions? A line contains these points. Select all the equations that represent this line. All right, well, yeah, this one's a little weird because I wish this would have been worded better because that implies a line, right? Like a straight line, linear. And all of those are lines except for which one? Yeah, the last one is quadratic. Okay, but if you plug in those points, if you plug in 0, 0, and 1, 4, They actually work on the quadratic one. But let's worry about that one later. In order for this to be true, that you have to be able to plug them in, and it works for all of them, right? So if I plug in 0, 0, is 0 plus 4 equal to 0? No, so A failed. It can't be A. Is 4 times 0, 0? Is 4 times 0, 0? Yes, it is. Is 4 times 1, 4? Yes, it is. So B works for both of them. Uh, let's see. If I plug in a 0, is 4 times 0, 0? Yes, it is. Really, you know what? I already know this is going to be the case, because this is the exact same thing as B. It's just anything minus 0 is itself. So that's the same thing as saying y equals 4x. That's just, they wrote it in point slope. But that one will work. X equals 4y. Yeah, 4 times 0 is 0. But look, when I plug in the second one there, is 4 times 4 equal to 1? No, so it can't be D. Okay. E is if I plug in 0.25 times 0. Yeah, the only thing they did here is they took the y equals 4x and they divided by 4. When you divide something by 4, it's the same thing as multiplying by 0.25. Because what's in front of the y? A 1. What's underneath the y? A 4. 1 over 4 is equal to 0.25. So actually that one's going to work too. And then I sent you, did anybody actually look at the answers that I sent out? Because I'm pretty sure this was not going to be, because it's not a line. But I'm not. Let me double check to be sure. Because if they would have used function, then yeah, it's included, but not line, because that's not a line. What would that look like on a graph? It's a parabola. Yeah, there's no F. It's just B, C, and E. So it actually, those points actually do work, but since F is not a line, it doesn't count. Read, you understand that? This is a parabola because it's quadratic, and they use the word line. F is a function that's defined by there. Oh yeah, nobody got this one. If f at x plus 3 is equal to x squared plus kx minus 21, what is the value of k? So the only thing you have to do is get this x plus 3 and plug in for the x's and then simplify and see what ends up in the middle. K is the b value. See what ends up in the middle. So if I were to do that, f at x plus 3 is equal to x plus 3 squared minus, this is not an easy problem. I'm not going to say that it's easy, but ZOCs, they have different levels. That's how people separate from themselves. So like once you simplify, whatever ends up being in the K, that's what you would put. X plus 3 squared. You cannot distribute the square. The one thing you cannot distribute over addition. I don't have to do this, but I'll show it to you because if not, you won't understand. I'm really just rewriting this as x plus 3 times x plus 3. I'll keep everything else the same for right now. So how are you going to multiply x plus 3 times x plus 3? FOIL. So that is x squared plus 3x plus 3x plus 9. Over here I distribute minus 2x minus 6 minus 24. I won't even waste my time combining all of the like terms. Did I do something wrong, Marquise? You gave me like a weird face. Since all I want to know is what's k, k is the b, so let's just combine all the terms that have the x's on it. 3 plus 3 is Yeah, minus 2 is so K on the Google form you would just write 4. And you follow that or what? Yeah, all you're doing is replacing the x's with x plus 3's. It's not an easy one. I'm not trying to say like it's easy, but there's gonna be different types of forms, and that's how they separate the haves from the have-nots. Um, the Water Watch program is encouraging customers to reduce the amount of water they use each day. The program is selling low-flow shower heads, which use 2 gallons of water per minute for $54 each. A family currently has a shower head that uses 5 gallons of water per minute and is considering replacing it with one of the low-flow shower heads. The family uses a shower an average of 20 minutes per day and pays $0.002 per gallon of water. Determine the number of days that the family will start saving money. Okay. All right. So let's come up with a 2 gallons per minute for an average of 20 minutes. All right. Let's define a variable. Let's let x be the number of days. And if you want to start saving money, then let's let y be the cost. So if we have 2 unknowns, we have to have 2 equations. So let's let one equation be how much they would be spending for the low flow, and then let's let one equation be with whatever their current shower head is. And then we'll bring these together in the system. So right now, the cost of the low flow per day. Now, they're showering for 20 minutes. And the low flow uses cost per day. I think there's an easier way to write this, but try to follow me here. Because I guess we could also do a dimensional analysis, but that might make things even harder to understand. So just try to look. There's going to be an x here, okay, which x stands for days. So what I need to go here would be how much they're spending per day, if they were going to use the low flow. The flat cost is easy. How much are they spending for the low flow? Like what's the flat fee? The cost of the tank itself, which would be $54. But I need to know how much you're spending per day. That $54 is just for the wait. The program is selling low flow shower heads. Yeah. So each low flow shower head is $54. So if it uses 2 gallons of water per minute, and the family uses the shower for 20 minutes, how many gallons are they going to use? There would be 40 because there's 2 for every. Do you want me to write it out as a dimensional analysis? Because we can turn gallons per minute into cost per day. Yeah, watch it. Let's do it that way. Maybe that'll make more sense. Watch this. Let's do a dimensional analysis. Let's do 2 gallons per minute, and I want to turn that into cost per day. Okay. So let's first change the minutes into days. Now we're not going to do a regular conversion of how many minutes are there in a day, because how many minutes are they using? All we care about is how long they're using the shower head for. So to turn minutes per day, how many minutes are they using the shower in one day? 20. So times 20 minutes to get the minutes to cancel, and that's going to give me the days I wanted on the bottom, because the minutes are going to cancel out. But then I also need to figure out cost. Okay, I need to turn gallons into price. So for 1 gallon, they pay .002 dollars. That's what's going to get the gallons to cancel out. Now I'm at dollars per day. So all I had to do is multiply all those numbers. What is 2 times 20 times .002? Because that leaves me at dollars over days. What is, do I need to do it myself? 2 times 20 times .002. I'm getting .08. All right. So that equation is going to be .08x plus 54. Can I erase that or erase it already? You don't understand how I got that? For the low flow shower head, the ratio they gave me, all they really told me was that it uses 2 gallons per minute. But for the purposes of the equation, I need this ratio to relate days and cost. So I did a dimensional analysis, which is what you should have learned before you got to me, way back in like September. So I took the 2 gallons per minute. The way you get a unit to cancel out is by changing the location. So like gallons is in the top, so I need to cancel and put gallons in the bottom. And see, the reason why dimensional analysis works is because you're multiplying, but because every fraction, the numerator and the denominator are supposed to be equivalent, what's anything divided by itself? Is 1. So you're really, each time you're just multiplying by 1. So now I didn't attack gallons first, I attacked minutes first. This minutes is on the bottom, so on my next fraction I put minutes on the top. That's what's going to get it to cancel. Now, even though there are not 20 minutes in a day, all we care about is shower use. So if we wanted to convert minutes to days, how many minutes per day are they using the shower? 20. So I put the 20 on top. 20 minutes is the same as 1 day. Anything divided by itself is 1. That gets the minutes to cancel, and it leaves me with days on the bottom. That's what I want. That's what I want my ratio to be. Okay? But I still needed to convert gallons to dollars because my 2 variables are cost and days. So I took care of the day part. Now I got to take care of the dollar part. So if gallons started on the top, in order to get it to cancel, I need to put gallons on the bottom. Now, what is equivalent to 1 gallon in dollars? How many dollars are you spending on gallons? Well, that .002. So now all I have to do is multiply. This is just for the units to take care of themselves, for the units to cancel. What am I multiplying? Well, on the bottom, I just have 1 times 1 times 1, which is 1. I don't have a denominator. On the top, it's 2 times 20 times .02. Whatever I get there is going to be, whatever that number is going to be representative of dollars per day. Now, the second one should be easier to write. There is no flat cost because it's already what they currently have. They already have a shower head. So all we got to see is how much they're spending. Currently, they're using 5 gallons of. The family has a shower head that's using 5. Oh, do we have to do the same thing? Yeah. 5 gallons of water per minute. Yeah, we have to do the same thing with the 5. There's no flat cost because they don't have to pay for equipment. But for the second equation, instead of doing 2 times 20 times .002, we got to do it with a 5. 5 times 20 times .002, which should be 0.2. I'm doing it in my head. Can you verify that? With the y-intercepting 0. Did I do that right or wrong? Yeah, 0.2. Okay. So now, if you want to know what's the break-even point, how many days before they start saving? Remember we did, didn't we do the one in here with a taxi cab company, and we were comparing different taxi rates, and then we talked about the break-even point where they broke even, and then after that point, the one that was charging like less per mile is the one that gave you the bigger savings. So at the very beginning, which one here is going to be cheaper? Well, the current one, because I didn't have to pay for the shower head. But eventually, as more time, as x keeps on getting bigger and bigger, as more days pass by, because I'm spending less per day with the new shower head, eventually they're going to hit a break-even point, and then after that point is when you're going to start saving money with the low flow. So you would just make those two equal to each other. 0.008 x plus 54 is equal to 0.02 x. Put all the x's on the same side. So 54 is equal to 0.2. I can just do it already. 0.2 minus 0.8 is 0.12. Is 0.12x. And then just divide by 0.12. It looks like it's going to take a while. 54 divided by 0.12. 450 days. So it'll take a little bit over a year. After 450 days of some saving money. And do you follow me now or no? It's the same, like, because I think you're hung up on the dimensional analysis part. So the question, which is what tells us what our variables are, want to know the number of days in which, when you start saving money, that means that the cost is going to be equal. So that determines our two variables. But when you talk about slope, slope has to be change in y over change in x. My y is cost, my x is days. They weren't giving me those units. They were giving me gallons and minutes, gallons per minute. I had to convert that into cost per days. So you saw me do it with the first one, with the low flow one, where it was 2 gallons per minute. Instead of writing it back on the board all over again, and since we already knew we were going to just multiply throughout, I did the same thing, but just with 5 instead of 2. That's the only difference. Yeah. Well, because the point 2 is, unless I did it wrong, I did it in my head, but 5, it was 5. Okay, then we had, then the same time we did, like last time we did 2 times 20, so I did 5 times 20, which gives me 100, and then 100 times 0.002 gives me 0.2. So now that becomes my slope. Okay. 5 times 20, instead of 2 times 20, 5 times 20, but then times the 0.2, the 0.002. So like with the, another way you can, with the current shower head, these people are spending 20 cents a day. With the new one, they'll only be spending 8 cents a day. This function represents the radius of a circle for a given area. According to the graph, what is the look again, average rate of change? What does average rate of change mean? It's slope, okay? And the x-axis is square feet. So they're giving me, the 2 points they're giving me are 3 and 7. I gotta see what the y's are that go with it. Does it say approximate? Yeah, approximate is good also, because this is a little iffy here. With 3, what does it appear to be on the radius, on the y-axis? That appears to be a 1.0, which is 1. And then on the 7, that was a little bit more exact. That appears to be at 1.5. So now just slope formula 1.5 minus 1, 7 minus 3 is going to be 0.5 over 4. That should be this one. If I'm doing it right in my head, 0.125 feet per square feet. Any questions there? And you can go, you can do the thumbs up. What are the, okay, we did this earlier this year. What do you call the zeros of a function? What's another name for the zeros of the function? Say it again. Solutions, yeah. Roots. And that probably the best one here would be understanding the next intercept. What we're looking for specifically is what is the value of x when y is 0. I would assume the majority of you would probably use quadratic formula, especially considering that the formula is on the reference sheet. These numbers are kind of big, you might struggle with them. I know Anne, my good friend Anne over here, she's not afraid of factoring, and since she sees that all these have a 3 in common, I probably do factoring too, just because it's quicker. By getting that 3 out, now the a becomes 1. Can you think of two numbers that multiply to give you negative 60 and add up to negative 11? The other way around. Negative 15 and positive. They have to add up to the negative. The bigger one has to be negative. If you use quadratic formula, you end up with the same answer, but I just saved myself some time. X minus 15 would then be equal to 0. X plus 4 would be equal to 0. So x is equal to 15. X is equal to negative 4. Those are the ones you would have selected. Quadratic formula will give you the same thing. And did you do factoring? You did. If you're good with your times table, factoring saves you time. Now, factoring won't always work. Just because Anne's really good at factoring, she might try factoring, and she might not be able to find this combination of numbers that multiplies to give you that and adds to that. And if that's the case, then you have to use quadratic formula. Because that means that the zeros are irrational. So you'll get into, there's a big chunk of Algebra 2 that's dedicated to that. Well, remind me to talk to you at the end of class. Marquise, you too. During the first day of the Can's Goods Drive, Jasmine's homeroom teacher, something because I can't see it being blocked out, collected 2 cans. Jasmine's homeroom teacher collected 2 cans. During the third day, the teacher collected 8 cans. Let D represent each collection day and N represent the number of canned goods. Based on this situation, Jasmine claimed that the number of canned goods collected can be modeled by an exponential function. What is the number of canned goods collected on the 6th day based on the exponential model? So let's see. On the first day, there was 2. During the second day, they don't tell us. But on the third day, there was 8. Let D represent the day, and then N is the number of canned goods. Based on this, okay. There's a more precise way to do this, where you probably wouldn't have to guess as check as much, but we haven't gone over this. But let me go over it now. This is the nice thing about these reviews. If you can remember this, there's something called the geometric mean. See, they give me the first day, they give me the second day. They tell me that this is exponential. Now remember, exponential was the form for geometric. It means to go from one to the next, you have to multiply. So it's saying 2 times some common ratio gives you the second day, and then once I know that second day, then you multiply again and you would get 8. So you might be able to look at that and go, oh, it's going to be 4, because 2 times 2 is 4, 4 times 2 is 8. But if you're ever not sure, like, look, if you know that it's exponential, and you're looking for the number in between, take the square root of the product of the 2 numbers. You guys are familiar with arithmetic. If they would have said that it was a linear model, then if you want to find the number in the middle, you just add and divide by 2. But for geometric mean, what's 2 times 8? And what's the square root of 16? So once you know that there's a 4 there, well, now you can just find this recursively. So this is going to be day 1, day 2, day 3. So let's go day 4, day 5, and then 1 is day 6. What's the common ratio here? What are we multiplying by? Yeah, we're multiplying by 2, so then it would be 16, 32, and then finally on the 6th day, it would be 64. Based on what you know now, I can't think of an easier way to show this to you. A lot of times on these standardized tests, there'll be questions that they'll throw in just as like experimental questions, just to see where they won't be point back. They don't tell us any of this stuff. So, just because, oh, but we haven't gone over this exactly in this detail, that doesn't mean it won't show up. They do put some higher, like abstract type questions where you have to go beyond what you've been taught. Have we gone over exponential models? Yes. Have we gone over geometric sequences? Yeah. But something like this where you have to find the one in the middle to then get the common ratio, maybe not exactly, but that doesn't mean it won't show up. Kiara, anything? No? I see the free formula there, so you might want to remember. Geometric mean it's called. It's when you look it up in books, it's just if you know it's geometric, they tell you square root of x times y, where x and y are the endpoints and the one in the middle. The process of completing the square can be used to calculate the width of a storage bin that gives a maximum area. What's the value? Okay. See here, look, we went over completing the square. We definitely went over it. But this is kind of a little bit different than when we did it because this is using it for a function. So watch, try to follow me here. Well, there's actually two ways I can show you this. I can show you a much easier way, but I don't know if you're going to make the connection. See, the way we have gone over this, does anybody remember what this kind of looks like up here? Kind of a parabola, but what form of a parabola? Vertex form, right? Do you remember vertex form? N is equal to. Do you remember that from first semester in the very beginning from here? And if that were the case, well, what are they looking for? They're looking for K, right? Well, I showed you how to find K. That would probably be the easier way to do it. I can do this also by completing the square, but it might be a little more complicated for you. You might not understand it. So, you tell me, look here, I'll do it the easy way, and then if you want me to do it by completing the square, I'll do it by completing the square. I'm gonna circumvent completing the square. If you remember, now this h here, which look at normally we have to calculate h, but look at it, they've already calculated it for us. What's the h here? The h is 9, but you know what? I have to do one more thing. Because in order to get the a's to match up, factor out. You see how this -2 is on the outside? I would have to bring it out up here too. This would be -2 times x squared minus 18x. Have I lost anybody yet? If I factor that out. Well, I'm gonna have to complete the square. I'm not gonna be able to do it without it. I need a constant. If I work without it. Well, maybe it would work without it. You mind if I just do this on my own real quick just to calculate it to see if it's the same because I don't want to confuse you. X plus 18x plus 81 62. Do me a favor, can you guys check to see if tell me what 18 times 9 is. Is Is it 162? Okay, perfect. And you know what? Forget all this nonsense. You just keep it easy. How it was before. Do you understand how I got h? Okay, so once I have that h, just plug it in for the x's up here. That's what I was doing now. I did it synthetically, but k, that k that we were looking for, that's out here, it ends up being 162. Should be positive. You got negative? Negative 2 times 81, and then plus 36 times 9. Negative 2 times 81, that's negative 162. And what's 36 times 9? 324. So what's 162 plus 324? Is that positive 162? Do you guys want to see me do it by completing the square, or do you want to see that too? Yeah. So if you did it by completing the square, then you have to start doing what I did up on the top. Okay, we got to see how we can turn this into the bottom. So you have to bring out the negative 2, which would give you x squared minus 18x. Does anybody remember the formula for completing the square? What was it? B squared over 4a. But okay, now my b would be negative 18. So negative 18 squared over 4 times 1. Because this negative 2 was factored out already. We're only focusing on this. That's what we want to complete the square with. What's 18 squared divided by 4? What is it, 81? Okay. So what happens then, I take what I already had, and I'm saying, okay, well, in order to be able to make this parentheses turn into this one, I have to add 81 in the parentheses. In order to make it a perfect square trinomial, which I can turn into that, I have to add it to 81. But overall, as an expression, I'm not really adding 81 because I had a negative 2 on the outside. What I'm really adding to that right side as a whole is whatever negative 2 times 81 is. What's negative 2 times 81? It's negative 162. Well, how do I balance that? How can I keep this to be equivalent with that? Because I'm putting in an extra negative 162 that wasn't there before. You would have to add 162 on the outside. And that's why 162 on the outside ends up being, I think that's more confusing for you guys to understand. And if you simplify this, you get what we started with. I think I'll do one more. An equation is shown. Which number appears on the other side of the equal sign? Okay, see, this would be more appropriate. This one here I would expect you to know. Which number appears on the other side of the equal sign after you complete the square? Well, 19 is not a perfect square, so I have to move 19 to the other side by making it negative 19. So now when I complete the square, Angel said b squared over 4a is 64 over 4, which is 16. So I would have to get that 16 and add it to both sides. On the left side, that just completes the square to get my parentheses. But on the other side, what's negative 19 plus 16? Negative 3. That would be the answer. Once you complete the square, you would get negative 3 on the other side. This is a perfect square trinomial. Here I would get x plus 4 squared. On the other side, I would get negative 3. The other side of the equal sign. Of the equal sign. It does say on the other side of the equal sign. All right, I'll see you tomorrow.